It's a very interesting math ACT problem, which is discussed in my book, Advanced ACT Math, where I go through multiple solutions to real problems. The interesting thing about this one particularly is that it's not that difficult a problem. It would be difficult for a weaker student, and it definitely tests certain things, but it's almost impossible to do except directly. Now, there are methods using substituting numbers and graphing, which are good for other problems and sometimes a better way. For this one, they become terrific time traps. We just multiply this out. We have negative 56 x to the ninth. We add the exponents when you're multiplying. Negative times negative is positive. We have plus 24 x to the eighth, which is a. Now, if you try making up a number, if you plug in 1, if you plug in 2, it's going to get you very large numbers. We might look into that also. But if you plug in 1, and this is also kind of a little nasty, in the expression at the top, you just look at the coefficients when you plug in 1 because the x's are all 1. And then this becomes negative 8 times 4, which is negative 32. Now you can go through each of these and add the coefficients. We get negative 32, negative 80, negative 32, negative 80, and negative 32. So we have 3 answer choices, and from there, if you didn't figure out that you should just multiply things out or figure out what the right answer should be, then you can guess between the three of them. Again, this is not a good way of doing it, but it's kind of interesting to look at. Now, if you plug in negative 1, it's a little tricky because negative number to an odd power is negative, and negative times negative is positive. So we have 8 times 7 plus 3. I'm not going to go into a lot of detail on this. That's 80. If you look at A, that's going to be 56 plus 24, which is 80. B would be 56 minus 24, was like 32. C is negative 56 minus 24, which is negative 80. D is negative 56 plus 24, which is negative 32. And E would also be negative 32. So then you could know that would be A from there. If you tried plugging in, you could plug in like 1.1 with your calculator. If you try plugging in 2, you're going to get pretty big numbers. If we plug in 2, then we get, it's going to go into the kind of trouble you get into the time traps involved. Don't see that's not the way to do it. So we have 7 times 64, which is 7 times 6 is 42, 7 times 4 is 28. So is that like 448? Minus 3 times 32 minus 96. So we have minus 64 times 452. Yeah, I mean, you can keep going and you'll get that A is the same. We can do that with a calculator and show that, but just to show you the kind of mess you get into. Now you can also get into a mess graphing. Some of the top, I already have that in there. And the problem is, initially, if you type that in, you're going to get something like this. Then we zoom in, and that's the best way. It's still very flat. Now, if we do negative 56, entering this is difficult on the computer and probably worse with a calculator. Try to show it to you on the calculator here, but plus 24 x to the 8th. And it's on top of it. And again, to be able to see, well, that must be the right answer. It's on top of it. That's the first one. So technically, and now here I'll do a cut and paste, which you wouldn't be able to do that with a calculator, I don't think. And now this one, if you can see which one is which, then this one is not on top of the other one, so that's not the answer. You go through all the other solutions and see that. So again, in this case, it's a big time trap to use numeric graphing methods. You want to know how to use those methods, but it's also important to understand when they try to trick you. And this is an example where they're tricking you, getting you into a lot of trouble using a certain method.